రేపు పొద్దున్న 7ంటికి వస్తావు కదా? సరే మరి.
Hello everyone, this is Prashanth. Hope I am audible to you clearly. Now, this is my first video and I am checking whether this is actually working out well or not, and hope there are no delays or there is no lag in the everyday live class. So for first year with today's class, we are going to start with motion in 1D. So in motion in 1D, we will do that. Gradually, we will do entire first year syllabus. So before I start, I want you to share these videos to all of your friends. And I have given a commitment that I'll upload all of my videos into the YouTube soon. This course, what I'll do is I'll every day do first year from 6 to 7 and 7 to 8 I'll do second year portion. So every day there will be a live class going on. So please do share this information to all of your friends, and every day we'll be uploading a video. So first we'll start with motion in one dimension. then we'll do entire first year syllabus, then in the other track we'll do second year portion. Okay, so now let's start our today's class. So in today's class I want you to just concentrate only on the basics. I'll just check whether everything is working fine or not, then I'll do doubt session everything later. But for today I'm just checking how the session is going on and whether everything is working out fine or not. Okay, so now in today's class first we'll start with basic information. So motion in one dimension is what we are going to see. Now what is your, I mean, different types of motion? What are the different types of motion that you have is translational motion is one type of motion. Second, rotation, then followed by general motion, which is combination of translation plus rotation together. Okay, translation plus rotation together, that will give you general motion. Okay, now for each of these there are two main aspects. One is the kinematics part and other one is dynamics part. Okay, so kinematics part and dynamics part we'll do for these kinds of motion. Kinematics in the sense, okay, without talking of force. Okay, kinematics is without talking of force. You talk of velocity, initial velocity, final velocity, acceleration, time, displacement, all these values you are going to calculate in kinematics part. In dynamics part you will talk of force. Okay, so for now we'll stick only to the kinematics part. Okay, so this is what you have. Okay, so your body usually in one dimension, okay, it will undergo different types of motion: translation, rotation and general motion. If you want the examples for this part, for translation I can say a block just simply going in a straight line like this is translation. Another example that I can give is just simply you take a block and throw it with some initial velocity u upwards. Okay, here in one dimension only either x or y coordinate, only one of these will change. Okay, right, so in this particular dimension only one or x or y coordinate will change. In rotation both x and y will change. In general motion x y, and if it is in 3D x y z, all the coordinates will change. So now this is the meaning of the word motion. Okay, like fan rotating is kind of rotation. Okay, right, next if you take the wheel will not undergo. If you take a point on the wheel, this wheel undergoes general motion like this. Okay, this wheel undergoes, a point on the wheel undergoes general motion like this. So like this you have different motions in translation, rotation, everything. Okay, so now in today's class we'll just see the basic stuff. So what is the basic stuff, I will tell you. So now if you are taking an object in motion, okay, there are different terms that you actually define for the body that is moving. You talk of speed, you talk of velocity, you talk of acceleration, you talk of time. Like this you will actually define different quantities. So all those different quantities we are going to define, and then we are going to apply them to the equations. Okay, so first we will only do the basics part. Now the first part that I want to explain is what is the difference between distance and displacement. Distance and displacement, what is the difference and what is the meaning of each is what we are going to see in today's class. Okay, now first we will do only basic things. So first of all, what is your distance means? Your distance is actual length of path covered by body. Actual length of path covered by body is your distance. Your displacement is, it is a vector. So if for a vector, we obviously know that there are two things that are actually defined. One is magnitude and other is direction. Magnitude is shortest distance. Magnitude is shortest distance between initial position and final position. And coming to your direction, it is a vector from initial position to, okay, arrow from initial position to final position, arrow. So that is your displacement. Okay, so distance, it is a scalar quantity. Displacement, it is a vector quantity. So for a vector, there will be two things. One is magnitude and other is direction. So magnitude is shortest distance between initial position and final position, and vector, displacement vector, is from initial position to final position. Like this, you will have the distance and displacement. Now what is that we are going to actually do is, for different scenarios with examples, I will explain what is distance and what is displacement. Okay, so let us start with basic ideas. Now for example, okay, so hope you have copied it down. So let us say there is a body, okay, example 1, it is going like this, it is traveling 1 meters towards north. A body has started at A, okay, within the plane of paper, this is your north, this is your south, this is your east, this is your west. Okay, so a body has undergone 1 meter distance, it has traveled in the north direction, then followed by 2 meters, let us say it is 3 meters towards north, 4 meters towards east, then followed by, let us say it has undergone another distance of, let us say it is 12 meters and reaching this point C like this, okay, or some point B like this. Now what is your question is, in this case, find distance and displacement. Find distance and displacement, that is your first question. Now for this question, if you ask me what is the answer, I'll say, okay, my answer is, when body travels from here to here, okay, first I'll try to calculate distance. So distance, I have told you, actual path covered by the body. So actual path in the sense, it has gone from here to here, the distance is 3. From here to here it is 4, 3 plus 4, 7, 7 plus 12, it is 19. So distance is 3 plus 4 plus 12, that is equal to, that will give you 12 plus 4, it is 16, 16 plus 3, it is 19 meters is the distance. Now coming to the displacement, okay, displacement magnitude I will give you, okay, so I should have asked my question clearly, it is magnitude of displacement, okay, but nowhere in the books, in the starting while you are solving, nobody will give you displacement. I mean, they will only give you what is the displacement, and they will just simply give you options, but it is a vector, you have to give the direction as well. Okay, but in the starting stage, it is, even though it is not mentioned, you have to consider only the magnitude. Now if you do so, what exactly happens here is, okay, so now from, you want the shortest distance, your shortest distance is, this is your shortest distance. Now if you are extending it like this, so here what happens is, this distance is 3 meters, this distance is 4 meters, so you want this straight line distance. So indirectly you have a right angle triangle with 4 here, 12 plus 3, it is 15. So your hypotenuse is, under root 4 square plus 15 square, that will give you I mean, because Pythagoras theorem, okay, this distance is, this is your hypotenuse. Hypotenuse is under root of opposite side square plus adjacent square, so that will give you under root 225 plus 4 square is 16, that will give you under root 241 like this. So this is your displacement. Okay, distance, total length of path, displacement, shortest distance. Okay, right? Next, one more example I'll give on this. Okay, hope you have copied it. So next question is, there is a body that is going in circle like this. Let us say it is starting at A. It has gone to some point B, point C, point D, point E like this. Now this point B makes an angle of theta, radius is R. What is the question is, in when the body goes from A to B, what is the distance? When body goes from A to C, what is the distance and displacement? In each of these cases, you are supposed to calculate your distance and displacement. Okay. Now find distance and displacement. Your second question is, find distance and displacement. That is your question. Okay, right. So now from here to here, you are supposed to calculate your distance and displacement. This angle is theta, radius is R. Okay, now here I want you to remember one thing. Theta, if it is 0, it comes to A again. If theta is 90 degrees or pi by 2 radians. Okay, if you do not know something, in the channel there is a video based on trigonometry and different geometrical dimensions. You can learn from that. If theta is 180 degrees, your answer is pi. If theta is 270 degrees, it is 3 pi by 2. Accordingly, you change the angle theta, you are going to get distance and displacement. Now first, in a loose way, I will explain. So from A to B, if you are doing, okay, first A to C I'll do, and then A to B I'll do it. So this is A, this is C. Now what is your distance means? Okay, your distance is this white color part. Okay, now if this radius is R, okay, in maths you must have learnt L, length of arc is R times theta in radians. Where your theta in radians is how much means, your theta in radians is theta in degrees by 180 degrees into pi radians. So according to that logic, okay, 90 degrees equivalent to pi by 2. So in from A to C, what is your distance means, your distance is R times pi by 2. Okay, this angle is 90 degrees. Okay, so when the angle is 90 degrees, L is equal to R times theta. So you are going to get, okay, you are going to get L is equal to R theta. So you are going to get this as your answer. Okay, now coming to the next part, displacement. Okay, indirectly magnitude of displacement. Your displacement magnitude is shortest distance. So this is your shortest distance. Now here these two sides are equal. So this part is R, this part is R. So it is R root 2 because Pythagoras theorem. It is under root R square plus R square, that will give you R root 2 as your displacement. So displacement is shortest distance. Distance is total length of path covered. Okay, right? Next, coming to the next part, if you are doing the same from A to D, okay, A to D like this. Now from A to D, how you are going to do this is, from A to D, if you are doing it from A to D, what happens is, this is A, this is D. Now from A to D, this angle is 180 degrees. So your distance is total length of arc. So from here to here, your arc length is, total circumference is 2 pi r. Half of it is pi r. So it is pi r is your distance. Displacement is shortest distance. So what is your shortest distance means, this pink color line is your shortest distance from initial position to final position. So how much is the displacement? Displacement is 2r. It is the straight line distance. Okay, like this from A to C, if you A to E, if you are calculating, your distance is total length of path covered, that is 3 pi r by 2. Shortest distance is once again R root 2. Okay, now how, for a general case, I will calculate in terms of theta, then I will change theta, I am going to get all these results. Okay, So how is that I'll get these general results? I'll explain now. Observe very carefully. So now coming to this general figure, your general figure that you are going to have is, so this is your circle. So within this circle, what is it we are going to do is, we are going to draw a bigger figure. Now your distance part is pretty obvious, only this length. This is your distance. How much is your distance means it is r times theta in radians. Okay, so I told you very clearly theta in radians is theta in degrees by 180 degrees into pi radians. So you have to substitute the value of angle. This arc length is your distance when it is going from A to B. Okay, now in place of theta, if you substitute 0, it will be B will be at this point. If theta is pi by 2, 90 degrees, it will be at this point. Theta is 180 degrees, it will be at this point. Like this, you can generalize this for all the points. Now the important part is displacement, that is your shortest distance. So you are supposed to calculate that shortest distance A to B like this. This is O. Now this magnitude of displacement is this shortest distance. This shortest distance, how you are going to calculate, I will tell you. This part is R, this part is R. This is A, this is B, this is C. If you assume, now in triangles, in school level you must have studied, if you have a triangle like this with A, B, C like this, and this angle is theta, you can write C square is equal to A square plus B square minus 2ab cos theta. Okay, accordingly you can transform this. For example, if theta is 90 degrees, this will become right angle triangle. So hypotenuse square is equal to A square plus B square like this. So using this relation, your C is under root r square plus r square minus 2r square times cos theta. So that will give you under root 2r square times 1 minus cos theta. So that will give you, now in maths, cos 2 theta can be written as 1 minus 2 sine square theta. Similarly, cos theta can be written as 1 minus 2 sine square theta by 2. Okay, so from here 1 minus cos theta can be replaced and written as 2 sine square theta by 2 sine square theta by 2. So that will give you under root 2r square times 2 sine square of theta by 2. So that will give you under root, okay, 2r square into 2, 4r square. So 4r square sine square theta by 2. That if you simplify, you are going to get 2r sine of theta by 2. Now if theta is 90 degrees, theta is 90 means you can substitute sine 90 by 2, sine 45. Sine 45 is 1 by root 2. So from A to this point, r root 2. Like this, if theta is 180 degrees, it is half circle. If theta is 270 degrees, it is 3/4 of the circle like this. Okay, so like this you can actually calculate your values for displacement and okay, you can calculate your displacement values like this. Okay, so let me check how the link or streaming is going. Just hold on. Okay, right, no issues. So we'll continue further. Okay, your next part is, let us say you are given a question of calculating your distance and displacement in a different scenario. For example, let us say a person is going on land, he is walking, he is starting at a velocity of walking is some 3 meters per second, and he is supposed to reach this point B. This distance is given as 4 meters per second. See, 4 meters, and total distance from here to here, let us say it is given as 10. Now the question is, let us say this is a river, water is flowing out like this. Okay, this is the bank part. Okay, so I'll put it, your white color one is bank. He should reach the opposite end like this. Now what is your question is, where should he, okay, his walking velocity is 3 meters per second, and let us say he can swim, okay, velocity of swim is 4 meters per second. Okay, he is traveling, he is starting from A and he is supposed to reach this point B, and total distance is given to you as 10 meters, and let us say this distance is given as 20 meters for you. Question is, where should he actually jump into the river? Okay, he is walking, he'll walk to some point C, till from A to C he is going to walk, and from C to B he is going to jump. Okay, he is jumping into the river. Now what is your question is, find where should he jump so that time to reach this opposite bank is minimum. Find where should he jump so that time to reach opposite bank is minimum. This is your question. Okay, so try this, then I will explain the solution. Okay, now so here distance total, how much he travels, that also we can calculate. When time is minimum, you calculate your distance traveled also. Okay, distance traveled is equal to dash. This is your second bit, this is your first bit. Okay, so these two values you are supposed to calculate. Now how is that you are going to do this? Observe carefully. So now let us say he has traveled a distance x. Now if he is traveling a distance of x, this distance will automatically become 10 minus x, and this width is given to you as 20 meters. Now so he is going to come from here to here, then he is going to jump into the river like this. Now your total time, okay, your total time is okay, distance by speed, because when bodies are moving with constant speed, what happens is your time is distance by speed. So your time to walk is distance by speed, that is equal to x by 3 plus, okay, and your time to walk is, this is I mean time to swim is under root 20 square plus 10 minus x whole square, hypotenuse square, by inside he is able to travel with a speed of 4. Now for time to be minimum, okay, whenever minimum time occurs, whenever minimum time t minimum occurs, what happens is your dt by dx is equal to 0. So according to that logic, okay, derivative of x by 3 is 1 by 3 plus 1 by 4 times 1 by 2 root of 20 square plus 10 minus x whole square is the derivative, times 2 times of 10 minus x. Okay, if you do not know how to take derivative, watch my derivatives video. This must be equal to 0. From this solve the value of x. Once you get the value of x, what is your total distance means, okay, your total distance traveled is it is x on the bank plus inside water it is under root 20 square plus 10 minus x whole square. Okay, so like this you have to solve the basic equations. Okay, now you simplify and then do the all the necessary required answers. Okay, displacement is anyhow fixed value. Okay, displacement is shortest distance. So if I put it with a different color here, this is your displacement. This displacement is under root 10 square plus 20 square. Okay, Pythagoras theorem, you can apply this and then get the required answer. Okay, right. Now we are going to continue further. So in other situations where motion of the body is involved, we need basic kinematics equations. So I'll come to that part separately. Now next is your basic idea of what is average average speed and average velocity. Now in maths the average is different, in physics the average is different. So what is the definition of average speed means? Your average speed is total distance by total time. Average velocity is total displacement by total time. So this is your average speed, this is your average velocity. Now based on this, if I just simply take simple basic questions, let us say from A to B a body travels with p kilometers per hour, it returns back with q kilometers per hour. Okay, it is going and coming back with, it is going with p kilometers per hour and it is coming back with q kilometers per hour. Question is find average speed and average velocity. Find average speed comma average velocity. This is your question. Now this is what you are supposed to calculate. Now in this case, how will you calculate means, many people will think what is the answer means, they'll just simply substitute p plus q by 2, but you cannot do that because nowhere in my definition, okay, in maths it is okay, sum of quantities by number of quantities is your average or mean value, but in physics you cannot do that. In physics our definition is for average speed it is total distance by total time, for average velocity it is total displacement by total time. Now a body comes from A to B and it is going back from B to A like this. Now if it is coming from A to B and going back from B to A, what is your displacement means? In this case your average velocity is 0 by time t1 plus t2 to come t1 to go back t2, but your average velocity magnitude is anyhow 0. Now we are supposed to calculate average speed. So what is your average speed? I will tell you. Now here body will go from A to B and body will come from B to A back again. So here two things are there. One is from A to B and other is from B to A. Now when the body is coming from A to B, what is your time means, let the distance be d. Okay, let the distance be d. Now if the distance is d, what is your distance means, what is your time means, because it is going with constant speed, time equal to distance by speed. So I am assuming d kilometers is the speed, so your time is distance d by p. Your time from B to A is distance d by q like this. So you have got time from A to B, you have got time from B to A. So now here what is your average speed means, your average speed is total distance. Total distance how much it is? D plus d. D to come till here, d from here to back that point. So that will give you d plus d by total time, total distance by total time. So that will give you 2d by d by p plus d by q. D if you take common out, you are going to get 2pq by p plus q. Okay, so maths definition average is different, physics definition average is different. Okay, so you have to calculate the values like this. Now here distance equal to speed into time equation I am going to use here because I have my bodies moving with constant speed. Okay, now in different situations they will not ask you simple questions directly like this, they'll ask with acceleration involved and all. So now next part, okay, this is only just the basic introduction, that's all. I'm not going to talk in detail further. But in which case, how to calculate time later, okay, coming soon part, I just want you to understand how will you calculate your average speed and average velocity in coming soon part, I will tell you. But in this coming soon, that means in the next upcoming lectures, I want you to understand, okay, here when body moves with constant speed, constant velocity, two things are there. In case of constant speed, in case of constant velocity, you can write distance is equal to speed into time. In place of constant velocity, you can write displacement is equal to velocity into time. Okay, so constant speed means body will not have any acceleration. Okay, now when acceleration is there, okay, when body moves with acceleration, there will be two things once again, but body moves with, I'll take constant acceleration. Constant acceleration means acceleration is not changing with respect to time. So in such a case, okay, your S bar is equal to U bar into T plus half A bar into T square equation. This will give you displacement. You can also use V square minus U square is equal to 2 times A bar dot S bar. Here also this is your displacement. Okay. So which equation to use means depending upon whatever is given in the question. Okay. Now in this also, okay, this directly gives you displacement. If you want distance, okay, now distance, for example, if body is coming with some initial velocity of u meters per second like this, on this body there is acceleration acting this way, which is obviously deceleration. So in this case what happens is, somewhere because this velocity and acceleration are in opposite direction, somewhere your body stops. Okay, it slows down and stops. Okay, so in same direction, while the body moves from here to here, distance and displacement both will be same. But when the body is coming and returning back like this, if you want distance, distance is from here to here it is d1, from here to here it is d2, d1 plus d2. If you are directly applying this equation, S bar is equal to u bar plus u bar into t plus half a bar into t square, you are going to get displacement. So when body is moving with constant acceleration, you have to look for this stopping point, and then accordingly you have to calculate your distance and displacement. And when body moves with variable acceleration, okay, when variable acceleration is involved, I want you to understand, when variable acceleration is present, okay, you have to go for differentiation and integration depending upon whatever is given in the question. Okay, so we'll start with equations of motion, and then we are going to utilize this average speed, average velocity, everything in the next class. Okay, so because this is only the beginning, I have just explained the basic content. So we'll continue from here in the next class tomorrow, same time. So every day these lectures will continue from 6 to 7 p.m. That's all for today. Thank you.